The rock and roll world is bringing me down. I'm gonna head on back to my little town. Pennies, but I made a pound. I've been high and felt so low. Wanted to stay, but I had to go.
Okay, great. So let's start. We have King Kenny here as usual, who is full of excitement about this lecture. A few little announcements. The final coursework specification is now on Moodle, so you'll see it there. The lecture recordings are also on Moodle. From all the lecture recordings from last week are there. And we do have the winners from last week's lab. So we have 5 winners from last week's lab that will all get free laptop covers. And the teaching assistant will send all the winners an email with the details about how they can pick up their free laptop cover. And this week's lab will be on the topic of debugging. It will be accompanied by another little tutorial, and you'll be able to immediately start applying these debugging strategies to your coursework. So you'll immediately be able to start working on the coursework, ask your coursework questions. And you might have heard me saying, or you might remember me saying, that one of the most difficult aspects of object-oriented design is trying to understand the control, the flow of control and the flow of information in object-oriented software. So the debugging strategies that we're going to talk about in the lab actually facilitate this. And I won't talk about it now, but I'll talk about it on Thursday. So yeah, I'm looking forward to that lab. And bring your questions to the lab on Thursday. Also, we have a dedicated chat on Teams just for questions about the coursework if you want to ask questions there. Yes, so the reason we have a dedicated channel just for questions is that if we do so, we'll have an entire history of the questions all together. So you can look at the previous questions and look at the previous answers, and maybe your answers have already been documented previously. Okay, so today's lecture is another topic that I really love. It's a very unusual topic, but it's very unfortunate that it's an unusual topic. It shouldn't be an unusual topic. The things we're talking about today are very important. Some of them are ridiculously important. I know it sounds funny, but it's actually true. And this should not be an unusual discussion, but in reality, it actually is an unusual discussion. And it's basically the implementation of, the start of the implementation. So how do you make the transition from a design to an implementation? That's what today's lecture is about. You've already seen the transition now from the requirement specification to a design. Now we're making the transition from the design to the implementation. And that transition is focused on protocols, which we're going to talk about. But before we jump in, here's a fun slide. Good versus bad design. We have here two diagrams. I hope that you guys can see them. They're both the maps of system calls that occur when a web server serves a single HTML file. Right? One of those maps or diagrams is from the Linux web server, and another one is from the Windows web server. Right? This is about hacking and web server hacking. So a hacker investigates each memory access to see if it is vulnerable to a buffer overflow attack. Right? That's accessing memory where you're not supposed to be able to access memory. The more system calls there are, the greater the risk is and the greater potential there is for some security vulnerabilities. So the question is, which one is which? Which diagram do you think represents the Linux system calls, and which diagram do you think represents the Windows system calls? That's the question. So I will put a poll here. So the upper is Linux, or the lower is Linux. If my chat works. So click on the one you think is represents the Linux system calls, and which one you think represents the Windows, which one you think is correct. And then the other question is, imagine you are hired as a software developer and your job is to look for vulnerabilities and in software, security vulnerabilities. You know, which piece of software would you rather be working on? That's another question. And you'll find the answer to that question, some discussion about that in Bob's Theory of Software Redevelopment, by the way. So the answer is the top one is Linux and the bottom one is Windows. So one of the web servers follows good design and one of them follows not good design, right? And this is one of the reasons that the Linux web servers are so popular. Okay, so what are protocols? A protocol is a set of signatures to which a class responds. So that's when you see the word signature and protocol, think of methods, method names, method parameters, and method return values. Yes, I like to spell Windows with a Z. Windows spelled with a Z is the American version of Windows. So a protocol is a set of signatures to which a class responds. It's the final step of the design and the first step of the implementation. So we're actually writing we're talking about writing method names, the input parameters, and the return parameters. Not the body of the methods, just the first line of a method. That's the protocol. So we construct a set of protocols for each class. These are specific signatures or methods that every class responds to, right? So good decisions require careful attention to refining responsibilities and naming the messages. So what a fun topic, right? Trying to think of good names for methods and thinking of good input parameters and thinking of good return parameters. Such an obvious discussion, but also it's a discussion that seldom takes place in any sort of depth or with any systematic methodology. This is the last part of the design. These protocols are actually included in the design specification, and they're actually documented on these class cards. So the goal here is to produce a precise and complete design. Right, and we're actually starting that process by specifying the protocols, or meaning specifying the methods that each class responds to, the input parameters, and the return values. Now remember, the other word we use for these methods are responsibilities. The term responsibility is used in the book on which these lectures are formulated. So we need to start our implementation for each class, right? So far, we have classes that have been defined in terms of contracts, responsibilities. We have a client point of view for each class. We have a server point of view for each class. And we start the implementation by specifying protocols for each contract, right? Remember, contracts are a set of responsibilities. Responsibilities are a set of methods. So really what we're doing is we're specifying a set of methods for each class, but not the whole implementation, just the first line of the method name, the method input parameters, and the return values. And by the way, we're focusing on the public methods, not private ones. So avoid over-specifying the detail, which normally advises against a protocol for private responsibilities. So we're not worried about private responsibilities. The person in charge of private responsibilities is the developer. Whoever the developer is that's assigned that class or who's working on that class, they decide what the private responsibilities are. So that is, private responsibilities are private methods inside of a class and private data like private member variables. But this might, you could maybe make an exception if two different people are working on parent and child classes. So isn't it funny that we have millions of method names, but we don't talk about them very much. So this is actually something we're going to talk about today. So method names, we know that method names are verbs, by the way. We all know that. Careful selection of method names is critical for maintaining and or reducing design complexity. So proper overloading can be an important vehicle, but be careful. It's confusing if one method name is used for two conceptually different things. That's something we definitely want to avoid. It can also be confusing if two different method names are used for the same conceptual entity or action. So a common example is print, right? Every object, it's very common for an object to know how to print itself, right? And in doing so, you always use the name print, right? The verb or the method name print for conceptually the same thing, right? You wouldn't want to use print as one name and like something different like print myself as a different name. That's not a very good example, but you'd only want to use the same print name and method name for all the objects that can print themselves. You wouldn't want to change those names. So some guidelines for choosing method names. The guidelines, so choosing method names is just as important as class names. Each method name should imply a unique intent. Use the same name everywhere for each conceptual operation. So Every object might know how to print itself. Every object might know how to display itself. Every object might know how to render itself. Every object knows how to instantiate itself. These are just some common examples. Every object might know how to delete itself, right? Those are just some common examples. Associate a single conceptual operation with each method name. And classes that fulfill the same responsibility should inherit it. And we're going to talk about this in detail. So if we think about our drawing editor example, so we have two classes. One's called drawing and one's called drawing element, and both have or respond to a message called display. Although their implementations might be very different, it's the same conceptual operation. So in other words, a drawing knows how to display itself, and a drawing element also knows how to display itself. In fact, a drawing could be consisting of a list of drawing elements. So the display method of the drawing object might just go through the list of drawing elements and ask them all to display themselves. Right? We could think about introducing an abstract class called drawable object, from which drawing and drawing element can inherit the display responsibility. That's one option. So revisit the design as a result of method name analysis and other aspects of the protocol definition often. So we may have to update the class cards, and if we introduce some new methods that expose ambiguities in the design or force modifications to the design. So we have a question. So what is private method usually do in a class? What a private method does in a class is up to the person who develops that class, who actually implements that class. Only that developer or that individual person is concerned with the private methods. Right? We're trying to create a software design in terms of clients and responsibilities, clients and servers, and clients cannot see private methods, so they're invisible for client objects. So we're not worried about those at this stage. So another guideline is to make protocols general. A protocol for a contract is a set of responsibilities that must cover the full generality of each responsibility in a contract. So a simple responsibility may only need one method signature. Here's an example. An array is responsible for knowing its size, so it might have only one method called size, which returns how long the array is. That's a simple example. But a more general example might need a number of different signatures and variants. So for example, an array that is responsible for enumerating over its elements. So we could imagine the following signatures for an array class, like find first, depending on some condition, right? Find the first element equal to 1, for example. Find the last element and return that element. Find all the array elements that satisfy a given condition and return an array of them. Remove some elements from an existing array depending on some given condition and return the copy of that array, but with the elements removed. We might perform a special operation on each element in an array, like adding some number, and there's no return value there. I would avoid this though, no pun intended. By default, return values should be true or false. By default, I'll repeat that. By default, Return values for methods should be true or false, not void. They're true if the method succeeds to completion. They're false. They return false if the method encounters an error. So that's the default for every method. For each reverse do, that could be another. So this is a set of protocols and signatures that are more offer more options, right? They offer more they cover more responsibilities. So let's see. Okay, I hit the wrong button. Okay, this is another topic that nobody talks about that's ridiculously important. Like the world is massively affected by the choice of defaults and default values. The more you pay attention to this, the more you'll realize how important choosing reasonable defaults is. For example, printing, very simple example. If I open up a PDF file and I choose print, right? How often does that happen? That happens billions of times every day around the world. Well, I have a choice. Is my default setting on the printer one-sided or single-sided, or is the default setting double-sided? Most people don't change default values. So if you choose single-sided as your default printing value, you may end up using, millions of more pages on a global scale than the person who chooses double-sided as the default print value. So these default values have massive, massive consequences, actually, in general. Classes are more easily used and more reusable if protocols are designed to reflect their different uses more accurately. So it's good to speculate on potential future use as well as immediate use, and it helps to abstract and generalize. So some guidelines for specifying protocols. Always start by defining the most general message or the most general method, allowing clients to specify all possible parameters. Provide good and carefully thought out default values for all of your parameters. Right? Analyze the likely different uses of those protocols and determine the best set of signatures that require only subsets of parameters in order to make the signature match most naturally to each likely use. Defaults are used for unspecified parameters. So let's look at an example. A complete specification of the display method in a drawing editor might identify the following parameters. So this is our drawing editor example where we're using this piece of software to draw figures like rectangles and ellipses and edges and arrows. You need a program like this if you're drawing UML diagrams, right? A drawing editor. So a display method for a rectangle, for example, might have different parameters, like, for example, which device to display the polygon on, right? It might also have a parameter for transforming the mapping of the object's coordinate system to the display coordinate system. So a polygon might have a local coordinate system, and the display to which it's rendered or drawn on might have another coordinate system, and there might be a transformation between those two coordinate systems. Every drawing editor and display has a clipping region. In other words, there's a visible square or a visible rectangle, and everything outside the visible rectangle is invisible or not displayed. That might be a parameter we need to specify. A drawing rule could also be a possible specification to a display method, how the images are overlaid. So for example, put this image in the front and put this image in the back. So the most general signature that needed to include all of these parameters, so that's 1, 2, 3, 4, those are 4 different parameters. The most general signature would include all 4 of these parameters, and then the other question is, well, what order should the parameters be specified? So this is something nobody thinks about, right? But it's actually important. So we have a guideline on parameters. The order of method parameters is based on the probability that the client will want to specify the parameters. In other words, the most popular input parameters come first, and the least popular input parameters come last. So we want to also specify reasonable defaults. Remember that the more parameters a method takes, the more difficult that method is to use, right? If you're trying to request a service from a server object, the more parameters you have to specify, the more difficult that method is to actually use. And we're always looking for the version of the methods that has no input parameters, or that requires no input parameters, right? Those are our favorite ones. And that's why we want to think carefully about our default values and always specify good defaults to make our lives better, to improve our lives. So we can define a default display, which is the active window. We can specify a default background color, for example, which is white, instead of requiring that the user always specifies the background color. We can specify a default clipping region, which is the entire display area. We can specify a default drawing rule, which is always on top. Whichever polygon we're drawing comes on top of the other ones. We can specify a default display and region. Well, the order in which these parameters are then listed is up for debate. Which ones are the most popular to change, or the most popular to specify? That's something that's up to debate, right? But in this example, we've chosen display and region as the most likely to be specified by the user, and transformation is the least likely. Yes, I mean, nobody's going to actually want to specify the transformation from one coordinate system to another. So given that discussion, we can then start specifying the display protocols, or the different versions of the display protocols. So the best one is at the top. There's the display, right, with no input parameters, using all default values. Here's a display that specifies the device, a specific device. Here's another version of the display method that specifies a clip region. Here's another version that specifies device and clip region. And these are listed from most popular to least popular. That's how these are listed. And so on. And here's the most complicated version of the display responsibility, where the developer has to supply 4 input parameters. Right? And we could also throw in 2 more, where the user gets to specify only the background color and only the clip region and background color, and so on. So there are lots of variants on this display responsibility. So when we're thinking about the order of importance or the precedence of parameters, we might actually modify the design, or we might refine the design. So this is something that you would discuss as a team, right? Usually when you're working on larger software projects, you're working in a team, right? And another alternative is to think about these accessor methods, right? Using accessor methods that say, for example, set display, and then you have a device as an input parameter. Or another method called set background color that specifies the background color. So that's quite obvious. Like all of your classes are going to introduce these set and get accessor methods, which are responsibilities, right? And what class should be given these responsibilities? Well, in this case, these responsibilities go into the drawable object, could go into the drawable object class, right? And these would map to, these all map to accessor methods, and accessor methods all map to class member variables, right? So this is just another example of thinking about more protocols to specify with your objects. So the final detailed design specification is the final step. Say that 10 times fast. So after we incorporate our protocols, we need to revisit our hierarchy and collaboration graphs to make sure that they've incorporated the latest protocol information and reflect the final design decisions, just in case the protocols end up modifying some of the designs. For a hierarchy graph, it's nice if you can fit a hierarchy graph of your entire software on a single page, right? A single page system overview is highly desirable. Include all the hierarchy roots on this page, and all the subsystems, if possible, include all first level children. And that is something that is going to be very helpful for your coursework too. Your coursework actually asks for an overview of your system design. But if you have subsystems in your design, or the top level of your hierarchy roots, you can include more pages if necessary, if you want to get more detail of subsystems or more detail on the hierarchies. What we're thinking about, by the way, we haven't decided yet, but we're also thinking about including a Doxygen bonus components to the coursework, because as you guys know now, you can use Doxygen to automatically generate hierarchy graphs and collaboration graphs. So we're thinking about incorporating sort of a bonus section into the coursework where you can use Doxygen to produce these graphs automatically without trying to do it by hand. And one of the benefits of this is that you can run Doxygen on existing software, and then it will produce the diagrams, and it will give you some visual representation of your existing software, right? Which is a nice, and getting that visual representation of the existing software can help you understand the software that's been given to you. If anybody has any opinions on that, if you would like to see that as a bonus, sort of a bonus aspect of the coursework, please let us know. So each class is fully specified, right, on a class card. So in the textbook, the textbook actually suggests transitioning from class cards to actual documents, right? So each class would have either its own page or a half page dedicated to it. So the class name, the parents' names, the child names, the list of responsibilities, the list of contracts, and the list of protocols, right? So that's a lot of information, and probably it needs anywhere from a half page to a full page to actually document. It might not, like adding these protocols will no longer fit on these nice little class cards. So if we want to have like the final document of our design, this is what it looks like. So a class has a class name, the abstract concrete identification at the top, the parent and child classes, references to the hierarchies and collaboration graph locations, a description of the class, its purpose, its intended use, expansion of original purpose on a class card, list each collaboration that the class is involved in, and for each new collaboration defined in this class, list the responsibilities that support it. For each responsibility, list signatures that implement the responsibility. Now, there's a note here, list private responsibilities. I would say, that's not necessary, right? There's a little note here, optional. I would say forget about the private responsibilities. Like I mentioned, the private responsibilities are decided by whoever implements the class. They're the person that has the final say on that. The full class design documentation may identify some special error messages or special performance requirements or any miscellaneous notes that are necessary. Okay, somebody says no oxygen. What is the meaning by first level children? Oh, okay. So a parent class might have child classes, right? That's what we mean by first level children. But if you think about it, a parent class can also have grandchildren, right? So you have parents, children, and then children of children or grandchildren. Those are second level children. So instead of first level, so children are first level children, and then children of children are second level children, or also called grandchildren. Yeah, I hope that answers that question. Okay, the subsystem documentation looks very similar to the class documentation. So a subsystem specification, the full design specification has the subsystem name at the top of the page, a list of all the subsystem classes that compose that subsystem, references to hierarchy and collaboration graph locations, a description of the subsystem, what its purpose is, what its intended use is. And again, we're not trying to squeeze these onto class cards anymore. A list of each contract supported by the system, and then for each contract supported by the subsystem, identify the class or subsystem to which the contract is delegated. Just so you know, in this coursework, we're not going into this much detail. This would be a good exercise and a good coursework if we had more time, and if the class was especially on design. Like, I took a module on object-oriented design. That's where this material has come from. And the whole module was dedicated to this topic. So we actually went through the process of creating class cards, modifying them over the time, and then going in at the end and producing these kind of documents that go into a great level of detail on the design as a coursework. I would say, like, if you can fit the documentation of a class onto a half page, that's good, but it might not always be possible. It just depends on how much intelligence the class has, right? A simple class you might be able to fit on a half page, but a more complicated class or a more intelligent class might require a full page. But again, you don't have to worry too much about that because this is not actually part of the coursework. This is the detail that you would need if you were designing a piece of software from scratch, right? A big piece of software from scratch. But you don't have that option in this coursework. You're given a piece of existing software for this coursework. And in fact, one of your big challenges is to figure out, here's a piece of software, a code base, what does the design look like? It's a reverse engineering challenge, actually. And that's it can be very, very challenging. If the original author followed all the rules, then it's going to be smooth. But if the original author does not follow the rules, like for example, coding conventions and object-oriented design guidelines, then the reverse engineering task becomes very more difficult. Actually, if there are no rules followed, which happens too, the reverse engineering can be impossible. And that's when you have a legacy piece of software or a legacy code. Okay, so the final design summary is one or more hierarchy graphs showing inheritance and overall class structure of the application, one or more collaboration graphs showing patterns of communications, class and subsystem specifications with the purpose, the relationships, and the collaborations and responsibilities and implementation notes. In this coursework, you're really only showing hierarchy graphs and collaboration graphs. So just on one page, really. Okay, we're about 5 minutes ahead of time, which is fine. I hope nobody minds. Are there any questions on protocols? I think the two things to think about are like the two or three important takeaways are method names are very important. You want to think carefully about method names. People don't think about them very much. You want to think very, very carefully about default values. So all of your variables should have reasonable default values, and the default values are incredibly important. They're very, very important and have massive implications because most default values are never changed. And you also want to think about the usability of your methods. So the more input parameters that a method requires, the more difficult it is to use, right? So you want to provide methods that have few input parameters for greater code reuse, but then that forces you to think of very good default values for the input parameters that are missing. So those are just some of the takeaways. Another takeaway is the default return value of a method is true or false. A lot of people choose void as their default return value, but this is a mistake. You're wasting a valuable piece of feedback, or you're not even exploiting the features that a good programming language offers by not using the return value. So a signature in this context is a method name, the input parameters to the method, and the return values. So it's like the first line of a method. So that's we call in this terminology we call that a signature, a method signature. So it's the method name and parameters and return values. Any other questions? I hope that everybody's looking forward to the tutorial on debugging. Debugging is one of my favorite topics, and I really enjoy talking about debugging. And I have thought about debugging for many, many years. Many, many years. And we're going to talk about that more on Thursday. Okay, I think we'll stop here. I don't see any other questions. If there are questions, please make a note of them, bring them to the lab on Thursday. And, oh, I did forget to mention one thing. I hope somebody noticed I added a bonus lecture to Moodle. I added a bonus lecture to last week's Moodle on job interviews, how to prepare for a job interview. I gave that lecture last year, but I recorded it. So it's archived and publicly available, and you can have a look at that. It's also on my YouTube channel. The quality of the lecture is not as high as it could be. If you're watching the lecture and you wish you could get a slightly better quality, please let me know. I think I still have the original recording, and I might be able to I think I could improve the quality. Yes, that's right. There is no task regarding documenting classes on the coursework issue sheet. I can only see class diagrams. That's right. So the documentation for this coursework is focused mostly around Javadoc. So making sure that all of your classes and methods are described using the Javadoc conventions. That's where the majority of your documentation is in this coursework. So what we've been talking about for the past 3 weeks is documenting the design. Javadoc is for documenting the implementation. But we hope that you're thinking about these things when you're doing your own development and you're extending the coursework, introducing new classes and new methods. Is there a glossary for all the different terminology? There is no glossary that I know of. Well, actually, let me just check. This is one of the books here. I can see if there's a glossary in there. I don't see a glossary in this book about the terms. I don't see a glossary. It does have an index, so you can look up all the terms, but I don't see any glossary. Here's the other book that I refer to a lot. I can check and see if there's a glossary. So no glossary here either. However, if you write your own glossary, that would be a perfect way to prepare for the exam. Very, very good way to prepare for the exam. I would recommend that. Any requirements on the video format? Do we need to show up? Yes, there are requirements on the video format. So the video format should be MPEG, a version of MPEG, any variant. So MPEG 4, the original MPEG, MPEG 2, because MPEG is the platform-independent video format. Do we need to show up? I'm not sure what that question means. The tutorial on Thursday is optional. You don't have to watch the tutorial on Thursday. The lab is not optional, but the tutorial part is. I hope that's what that question is. Oh, do you need to be in the video? You don't have to be in the video, no. What we're expecting in the video is, now I see, okay. You don't need to be in the video, no. We're expecting a screen capture video. So the screen capture video, you'll run your software, and you'll be capturing the screen as you're running the software. And you'll be demonstrating the different features you implemented. That's the idea. It's to show us that you've got the software up and running, that you've got the different features, and you're demonstrating the different features of your software. That's the idea. I would also recommend showing very briefly your Javadoc documentation, like saying, hey, this is what my Javadoc documentation looks like, and the source code looks like this. You can see that the source code follows all the coding conventions. Of course, you can't look at all the Javadoc and all the source code, but you could show a sample, like here's a sample of the Javadoc or a sample of my source code that looks amazing and follows all the conventions. So yes, the video is a demonstration of your software. Does that make sense? I hope I answered that question. You're starting your screen capture program, and then you're starting your software, and you're showing that your software works. Imagine you were trying to sell your software to a client. You'd have to give a demonstration, right? I wouldn't recommend necessarily a live demonstration of your software because it might crash. So instead of a live demonstration, you can give a screen capture demo of your software. If you use Maverick, basically we discussed the idea of submitting just the jar file, but it seems that there were complications in previous years when people only submitted the jar files. So this time we're actually just saying, okay, zip up your entire project folder, right? Every IDE creates its own project folder. The king just pressed a button here. So every IDE creates its own project folder. And we're just saying, okay, zip up your entire project folder, whether that be IntelliJ, Eclipse, or NetBeans, and then submit that. So zip it up, upload it to Moodle, and yes, the IDE folder, yes. Any other questions? How will Maven support our coursework then? So Maven is just the tool that builds your make files, right? So that it's, that's the job of Maven. So that's it. I don't know how else, what more there is to say about Maven. It's the tool that you use to build your make files, and that's it. And so when you submit that folder, that project folder that every IDE creates, that the Maven information will be included in there. So everything is included in that folder. Any other questions? I think the time is run out. Let's stop. Please write down more questions and bring them to the lab on Thursday. And thank you all for watching today, and I hope that you have a chance to look at these recorded lectures in the future as well. That's right. Somebody's made a comment that sometimes submitting just the jar causes dependency malfunctions. Yeah. So Pierre and I discussed this. Pierre is strongly in favor of submitting the whole project folder rather than just a jar file. I don't have a strong opinion on this. I'm just going with mostly Pierre's opinion. Yeah. Theoretically, it should be possible to submit a jar file, which I would prefer personally, but yeah, let's not like discuss this and agonize over this question forever. Okay, I'll see everybody on Thursday.